Okay, hello everyone, and welcome to the second day of the 5G and security session run by the UK5G security subgroup. I'm Mark Hawkins, the chair of the security subgroup, fellow at Kinetic, and been involved in 5G security for a number of years now, having been involved in one of the first projects looking at 5G and security over the past few years. For those of you who aren't familiar with UK5G, it's the innovation network for 5G ecosystem in the UK, and the security subgroup sits underneath the trials and testbed subgroup. So we've got a very strong interest in the security of the trials and testbeds which are going on in the UK. Security I really see as an enabler for unlocking the benefits of 5G. So I think it should be a really good session. So I'd like to hand over now to Francesca Saraville from Colt, who is the vice chair of the UK5G security subgroup and who's put together the fantastic program for today. So I'll hand over to Francesca to introduce the session today.
Thank you, Mark, and thank you everyone for joining the session. Good afternoon, everyone. I'm Francesca Saravalle, the Emerging Technology Director at Colt, and I'm also the Vice Chairman of the 5G Security Group. Now, today we will start with Ian Getz from Juniper talking about 5G security at the edge, and this will be followed by a panel session moderated by me, where we will be talking about how the deployment scenario will have an impact on the security posture of 5G services. We will follow up with a session on evolution of standard, both from a 3GPP perspective from Peter, Quickshot TCT, as well as from a best practice point of view from the BSI. And then finally, we will close the session with innovation in security, where we will look at industry-led initiative from Lorca, as well as more research-led topic from Toshiba Research Europe. So I hope you will enjoy the session. Thanks again for joining it. And I will hand over to Ivona for some housekeeping information. Thank you.
Thank you, Francesca. Thank you, Mark, and welcome everyone to this event. Just from the housekeeping, really very short, quick two announcements. If at any point there are any technical issues you experience, please raise your hand in the chat box at the bottom of your Zoom screen. And also we are running a Q&A throughout this event today. So if you have any questions to our presenters today, please type it into the Q&A box again at the bottom of your Zoom screen. And also if you have any questions specifically to the discussion panel speakers, please post those questions during the discussion panel. I think that's it from me. So again, thank you for joining, and I hope you enjoyed this event. So I'm now going to hand over to Ian. Ian, please go ahead.
Thanks very much for that. I'll just share my slides. So good afternoon, everyone. My name's Ian Getz. I'm the Chief Architect for Mobile Solutions in the EMEA Go-to-Market organization at Juniper Networks. And I'm going to talk about some of the issues around security for 5G and the edge, which we hear a lot about at the moment. Just to sort of set the scene, I mean, I've shown here a different way of looking at the classic 5G triangle of eMBB, IoT, and low latency. You know, most of the operators out there today are focused on consumer. They're consumer brands. They're selling bundles of smartphones, minutes, texts, and data. And they're selling those to consumers in the street. And what they're doing with 5G standalone and 5G non-standalone is basically more of the same 4G but faster. And hence I've shown eMBB in red, because 4G but faster generates little, if any, additional revenue for the operator, but significant extra cost. Now, if you go down to the bottom and you see URLLC, the ultra reliable low latency comms, or more accurately, low latency communications, and the use of IoT, that isn't just about pushing 5G new radio out into the networks. You have to move some network functionality. You have to move some of the application capability out to the edge of the network to deliver an overall package of low latency, and hence enable things like the private networks, the smart city applications, the connected autonomous vehicles, all the things that we see in people's vision statements for 5G coming forward. And that has quite an impact on thinking about security as we go forward. Now, if I do the build on the slide, the EMBB stuff obviously centers around mobile carriers, but wholesale carriers selling to those services to those mobile carriers, backhaul, hosting, that kind of thing, internet peering. Cloud providers are obviously looking to get into the edge. There's been a lot of announcements, things like Amazon getting involved with Vodafone and Verizon in what they call the edge, but is actually the mobile network core. But as you go down to the bottom, the whole supply chain becomes a lot more complicated. You've still got the mobile carriers, the wholesale carriers who could be supplying bandwidth services still, but could also now be getting private spectrum and offering private networks, or building neutral host systems into the fixed enterprise buildings that they offer. So again, already more complicated than we currently have. Cloud providers, again, looking at getting into the edge, but now in that situation of being able to take 5G core and 5G Open RAN capabilities into a customer premises and offer a private network as part of those low latency and enterprise vertical solutions. And then you get to smart cities, you get to the rail applications, the highways applications, and you could be finding cities are building the networks, hosting capacity on private spectrum for their own smart city, and then neutral host capacity back to the mobile operators. You could find industrial SIs are involved. You can find, you know, the railways are building their own 5G networks, etc. So a much more complex situation. Now, something else that drives the edge at the moment is the move towards Open RAN, which in turn is driven by a couple of things going on in the industry at the moment. One is that realization by the mobile operators that if you're really going to deliver the same sort of coverage and capacity and user experience on 5G that you have on 4G, you're not going to get any more users. Most countries are 100% plus penetrated for handsets. You're going to end up needing somewhere in the region of 3 to 3.5 times the number of cell sites. So that's a lot of cost for very little new revenue. And at the same time, your traditional 3 vendors is being reduced to 2 vendors by the geopolitical situation, with high-risk vendors being removed from networks, particularly in the UK and the US. So you have to look for alternatives, partly to keep vendor diversity and supply chain security, but also to try and bring in innovation and drive down cost. Yet to be proven with Open RAN, but that is one of the aims of it. Now, the technical specs, obviously, you're disaggregating the base station into the antenna unit, the distributed unit, and the central unit, and they can be flexibly put in different parts of the network between an edge cloud, a distributed processing unit, either in an intermediate point, for instance, maybe a street cabinet serving several radio units on lampposts down the street, or it could be a distributed unit on a generic server type infrastructure, obviously hardened, etc., sitting at the base of a tower. But this brings a whole new set of security concerns into the radio network that have to be addressed as part of rolling it out, whereas in the past you simply bought a base station cabinet from Ericsson, Nokia, or Huawei. So one of the things we've seen is operators interested to run in the same way they run IPsec tunnels on the backhaul connections from the base station N3 or S1 connections back up to the core security gateway, simply to protect the traffic from being intercepted. They're now interested in doing that on the F1 interface between the CU and the DU. Obviously, that's a lot more traffic. That's 25 gig per radio unit that's connected out there. So a significant amount of extra bandwidth. But you also have to think about the firewalling of access to those pieces of software for installing them, setting them up, updating them, the operating systems for the servers that you're going to be operating on, and actually segmenting that edge cloud so that the radio part can't get access to the application part and vice versa. So using micro-segmentation in the SDN overlay connectivity through those servers to make sure that different connectivity service chains can't actually get access to things they're not supposed to, as well as firewalling to get back to applications, getting back to public or private cloud back-end instances of things like you might be your City of London smart city application running on an edge cloud sitting in a basement somewhere in London. It still has to connect back to a data center that's running the kind of central processing of that with all the kind of back-end analytics and stuff like that. So quite a lot of extra security to think about there. Now, there's a lot of talk about edge and edge compute, and the edge is going to happen, and where is the edge? If you move your applications to the edge in a mobile network, you either have to move the core network with it, or at least the user plane part of the core network, or you have to address GTP in another way. And GTP is the mobile transport protocol between the base station and the core. And today there are 3 options, only 2 of which currently exist. So you either, in a non-standalone network, use the CUPS user plane of your EPC, move that out to the edge with an SX interface back to the control plane functions running in the telco cloud. Or you can put a complete EPC on site, which is what some people are doing with private networks. Or you can use, in a standalone situation, the release 15 user plane function with an N4 connection back to those control plane functions in the telco cloud, the AMF and SMF application and session management functions. Now that's great for defined area coverage, like a campus or a factory or a warehouse, where the devices that you're worried about don't enter and leave the area regularly. Because the problem with moving the up to release 15 user plane functions out to the edge is that you are anchored to an APN, which is the IP address on the IP side of the core network, and that has no handover capability. So if you're going to offer wide area services that need to move between base stations on a much wider area, CUPS and release 15 UPF don't allow you to do that. And they're the first thing that any attack from a compromised device hits in the network. So the first thing you're hitting is a user plane function, which is part of your core network, with an interface up into your core network control plane. So doing edge security and protecting your network using this is not exactly the best way of stopping attacks from compromised devices. In the future, we get the release 16 UPF, and that gives you handover of APN between UPF sites, but that still doesn't give you application state handover, so that you can hand over the state of your application as you move around the network. That's something for the operators to solve on their own. But again, same problem. The first thing you hit is the UPF itself. Now, this is all before we get the SEP in the future, the signaling aware security function that's coming in future releases. Now, in the middle, I've shown ETSI MEC, multi-access edge computing. That opens GTP at the edge. It doesn't terminate it. So you're not creating that APN handover anchor, but what you have is a group of APIs that enable you to hand over application state at the edge, deal with lawful intercept and billing and all that sort of thing. But crucially, you can now actually inspect traffic before it gets to the core network, before it gets to the applications. And therefore, you can run some form of edge security capability to allow largely the IoT device operators to opt into this service, because handsets tend to have a security capability. They're running Pulse, or they're running McAfee or F-Secure or some form of software. That's fine. They get regularly recharged when you next get to the office or into your car. An IoT device is working on a long-term battery, and running security software isn't necessarily the right way forward. So delivering MEC at the edge, I've shown here a service chain on an edge cloud. We take that IPsec tunnel from the base station up into the pre-aggregation router. So I've shown a wide area network here. That routes the N3 or S1, 4G or 5G, into the x86 servers that you're using there. The first thing you do is open the IPsec tunnel. You then run through the MEC server, that opens the GTP, then you run your applications. But you also have firewalls to break out to the back end of those applications that could be running in the public-private cloud. You also could be supplying that security service in itself. And the capabilities within the SDN service chain layer enable you to do that microsegmentation, so that one service chain for one particular application doesn't have to have any awareness or any accessibility to any other service chains, or the Open RAN service chains, or the core control service chains. So using that capability improves the security of the end service. Plus, you obviously have to put physical security, because this is likely to be a dark site and it's likely to be right out the edge of your network. Now, what we've been looking at in Juniper is how we take the concept that we run in the enterprise space called connected security into the 5G edge. So we've take the slide I've just shown you. We open the GTP with MEC. We now insert one of our virtual SRX security functions. It's now looking at the traffic. The policy on what traffic gets to it is determined by the MEC system. You've identified that, say, the packets are coming from the BMW cars or the London smart city application. They're steered into this system. The SRX examines them as a to do detection of attacks. If it has policy for the attacks it's seeing, it stops it. If it doesn't have policy, but it looks like it could be an attack, that's forwarded back up to the central policy analysis and push system, the policy enforcer. And usually new policy comes out and is pushed out to that hub site at the edge, in the edge compute area, within seconds. And not just that edge compute site, but every edge compute site in the country. So this is a way of adding the security that actually isn't there for 5G at the moment. 5G's security paradigm from the point of view of compromised devices is exactly the same as 2G. You have a SIM card, you're authenticated to the network, and then the device is trusted. As we go towards massive IoT and these devices are used, and we are seeing IoT devices being used as attack on the network and the applications, this is going to become a bigger and bigger problem. So this is one of the ways we think that bringing the edge together with security capability enables operators to define security at the edge of the network. So on that, thank you very much.
Ian, we are now going to move on to the discussion panel, which will be moderated by Francesca, and our speakers today include Ian, Peter Clemens, Dean Butley, and I'm handing over to you, Francesca.
Yeah, thank you. Hi again. I'll be moderating this session. Can you hear me? Yeah?
Yes.
Yes.
Yeah. Can you hear us?
Yes. I'll be moderating this session, which will focus on deployment scenario and how it affects the security posture of 5G services. In particular, we will be looking at 5G services running on a full standalone network and how this is more secure than a 5G services running on a non-standalone network. We will look at 5G and IoT services that leverage on edge capability and explore on whether these expose the services to a bigger attack surface. But we also be looking at how service provider can leverage the telco cloud to offer not only network as a services, but also security as a services. So here with me, I have thought leaders from the industry that are joining this discussion and sharing their view and their opinion. And I will let themselves to introduce themselves. I'll start with Dean. Please, could you introduce yourself?
Thanks, Francesca. Hi, I'm Dean Butley, also known as Disruptive Dean, as my Twitter alter ego. I'm an industry analyst and commentator, and I've been following the evolution of wireless networks and telecoms business models for a long time. I've got a particular interest at the moment in private 4G and 5G networks. I actually saw my first ever private cellular network in 2001. I think it was a 2G one. And it's interesting that it's suddenly become mainstream for enterprise and verticals as a concept in the last few years. So I'll touch on that.
Thank you, Dean. Peter, do you want to go next?
Yeah, okay. So my name's Peter Clemens. Actually, it's interesting that my interest in private networks goes back a long, long way. But really, the original networks, even before cellular, were the professional mobile radio networks. And it almost feels now as if we've gone full circle. And so it's I set up a relatively disruptive bespoke critical communications consultancy called Quixoticity in 2012. My background is very much in Tetra, the Tetra technology. But from 2012 onwards, the focus has been very much on the next generations to come. So mission critical LTE and 5G networks. And as you'll see, Quixoticity is a full member of ETSI and 3GPP.
Thank you, Peter. And Ian.
Yeah, well, I've kind of already introduced myself. Yeah. Ian Getz, I'm the Chief Architect for Mobile Solutions with Juniper Networks, looking at the 4G, 5G evolution, edge cloud, edge security, open RAN, etc. So, been in the industry, what, 30 odd years. So.
Thank you, everyone. So I would like to start with a question and a topic on 3GPP and their readiness. We know that we're not going to go into details because Peter is going to explain and have a presentation on it, but we know that 3GPP has introduced security enhancement in a phased approach, with a phase 1, mainly release 15, that was trying to address the gap in 4G security, and then phase 2, release 16, more to address the security requirement for verticals. Now, release 16, I think, has been finalized, right, from June this year, June 2020 this year.
Yeah, there's actually the next plenary is actually next week, but in the last plenary we had in June, we signed off. There are always some esoteric bits and pieces that need to be kind of signed off by the management team, but yeah, release 16 was complete.
I think there was some delay as well, right, because of this pandemic. But my question was whether, you know, are we done now with release 16? Has 3GPP covered everything? I know Ian was touching on some gaps. Is 3GPP going to fill in those gaps in release 17, or is going to be, you know, solved in some other ways as suggested by Ian? Ian, do you want to start, or Peter, on this topic?
Well, yeah, okay, I'll lead off. If you look at 5G, be it non-standalone or standalone at the moment, the methods of dealing with attacks coming up from compromised devices are still pretty much the same as they've been since the days of 2G. That doesn't get any kind of a capability in standards in 3GPP until we actually get the SEP coming out, which I can never remember what it stands for, but the SEPP something endpoint proxy, or security endpoint proxy. That is both signaling and user plane aware. So it requires a different set of skills than, let's just say, traditional vendors have. You tend to have security vendors and you tend to have core network signaling vendors. And the SEP requires that to be brought together, because the system has to look at both the signaling and the and on the user plane to deal with the different types of security attacks. And it also has to interoperate with the AMF, the SMF, and all the other functions that come in part of that 5G core. So that's not there yet, and we don't know how good that's going to be. At the moment, we've got this kind of lots of statements in the industry saying 5G is inherently secure, and yet actually from a compromised device point of view, there is this wide barn door that's been left open, which is there's nothing really to stop an attack going after the core network or the applications. So, you know, I think that's where the problem is.
There's going to be some interesting questions around compromised devices and, you know, whether it's outside of scope for 3GPP to actually improve device security. I mean, I've been speaking to a few companies recently that do things like hardware rooted trust, and actually potentially works the other way around, is how do I as the user trust the network? How do I know if there's any compromised network elements or virtual machines running in it? Which, given, you know, concentration on high risk vendors and so on, I can imagine that some applications might want to interrogate the network as much as vice versa.
Yeah, I think there's a lot more regarding mutual authentication within the release 16 and moving forward. I think what tends to happen when we move to a new generation is that you're very much kind of trying to, the focus is from the vendors and from the operators looking at new forms of revenue, and then the security community has to kind of catch up with that. I think what's good about 3GPP, and perhaps unlike, I mean, not every organization actually has a group that is actually dedicated to all security aspects. So the fact that there is an SA3 group that is kind of very closely connected to the other groups within 3GPP is definitely an advantage.
And Peter, do you see vertical participation in that group, SA3? Do you see also the vertical representation?
It's definitely gaining momentum now. I think release 16 was a very, very important release, and release 17 and probably release 18 as well are looking very, very much like being basically vertical focused releases. I mean, we were very lonely the public safety community and the mission critical community, we were very lonely back in 2011, 2012. There were just a few of us at the back of the room kind of gingerly raising our arm when we were a little bit worried about the direction of travel. But definitely since the beginning of 5G, I think that vendors and operators and just the general 3GPP community woke up to the fact that 5G would not be a success without the critical verticals and a number of other verticals as well.
Yeah, I agree. We need the demand side as well, because they really set the requirements, so it's very important. Do you think, Dan, just a question from my side is about, do you think these, in terms of 5G private networks, those verticals are keen are very focused on complying to 3GPP, or are also looking at other standards that are more industry specific?
I think there's going to be a variety. And I think that in some areas, or a good example might be something like utilities or in rail, where they will likely have a number of their own, both internal standards on security, but also priorities, legacy, and a range of other things that they need to consider. Simply because of the environment. I mean, I'm not a utilities specialist, but I would imagine that you've got a whole bunch of additional, security and risk factors where you've got high voltages, for example. And the same thing that in the oil industry, your primary requirement on security is flammable gases and making sure that things don't blow up. So there's additional dimensions to security that go beyond perhaps what we're used to thinking of purely from a network point of view.
Yeah, I agree. I think it's very important to, yes, comply to 3GPP, but we're seeing a mix of it where, verticals and private networks are also looking at compliance to, of course, ISO 27000 is key, because they need to comply with the information security, communication security, and operational security requirements, so that they can enable that business continuity, which is key for, especially critical IoT services. So yeah, so the other question I would like to ask is about the standalone versus non-standalone. So we know that if we look at the MNO deployment strategy, the mainstream is mainly non-standalone deployment, because they're focusing on enhanced mobile broadband use case. But we also know that there are innovative regulatory framework and licensing model that enable the verticals to own the spectrum and eventually own the network as well. So they can access this 5G broad ecosystem, and they can really pick and choose based on their deployment scenario. And my question is, are we seeing a trend from verticals to go for a full stack, which is full standalone stack? And if the answer is yes, what is the driver? Is it the capability of network slicing, service-driven network, API exposure, or is there a security element in it as well?
I would say that there's security and also a sort of a liability issue of who takes responsibility if something goes wrong. One of the things that we always talk about in 5G is, ultra reliable low latency networks, but as well as reliability, there's liability. And I think that there's an interesting question that, if you're a car manufacturer or an oil company, are you going to find a service provider that's prepared to take the legal risk if something goes wrong? And potentially, if a robot kills a machine, is it the service provider CEO who's in court, or the manufacturer? And so I think that there's some imperatives around that, as well as cost, and there's some other things which are more related to, particular use cases might have particular radio requirements with a different mix of up and downstream traffic patterns that makes sense for the macro network.
Yeah, I think we're still in the early days as well. And I think it also depends on, there are different types of verticals. So clearly there are ports, airports, factories of the future that are they're relatively confined to a specific space. And then at the same time, clearly there are public safety emergency services that need a much more kind of wide area type of network. So in that stage, what is likely to happen, I think, is that they will bully their selected mobile operator to implement standalone, perhaps as soon as possible, to get the additional features. Then there will be a requirement, public sector, or maybe some of the more kind of innovative initiatives at the moment, covering kind of wide area coverage, perhaps in rural areas, in building, kind of deep down in basements to solve that. So, but we're starting to see kind of airports, ports, but it's still non-standalone, because we've only just completed the release 16 really that has made standalone realistic. I mean, we're hearing Ericsson and Nokia now just starting to kind of make announcements about kind of German car makers and ports and airports. So.
Yeah.
I mean, you can get, I mean, one of the things that kept things in a public network on standalone was the availability of the core network infrastructure. A bit like why we ended up with release 99. You know, nobody was prepared to move to an IP-based soft switch at the time, so we ended up with an MSC with an IU interface on it. Similarly with non-standalone, no one was ready to move to a containerized, core network function, so we ended up with an EPC with an N3 on it. So you know, the power of the vendor was part of the problem there. The other thing is, you know, you can get standalone core network capability for industry verticals and stuff at the moment. You're probably not going to get it from one of the big vendors.
Yeah.
So that's another point. But on the emergency services point that Peter was making, I mean, one of the problems is that emergencies are a nasty habit of happening where they want to happen and not where there's coverage. And you know, if you look at the way the UK has addressed the emergency services network, etc., it's tried to extend 4G coverage on one of the operators. It's got an MVNO core type approach. But actually, if you look at going forward, how are we going to integrate the different types of technologies needed to provide coverage to first responders in any situation within the UK where you may have only a satellite that can cover the area? So if you can get an emergency vehicle in there that can maybe pop up a base station, activate some applications it's running on servers that are in the back of the vehicle, but have a heartbeat back to a control via a satellite or something, maybe mix and matching between mobile operators to provide a range of coverage, that's probably a better way forward.
I think as well, what you'll get, because of the only recent standardization of standalone, is that a lot of enterprises at the moment are more focused on private 4G rather than 5G. And there's dozens of providers of EPCs. You can have one running on a Raspberry Pi if you really want to. And I think that's probably also behind the fact if you look at what happened with the spectrum auctions with CBRS in the US recently, there's a lot of utility companies, quite a few oil companies that obviously are intending to build out their own private infrastructure. And utility companies are similar to the public safety in that, you know, your high voltage grid goes over the mountains and through the fields.
Yeah, absolutely.
I'll be very interested on how will evolve the responsibility model when we talk about 5G private networks, and whether this is going to, you know, replicate the shared model, that shared responsibility model that the cloud service provider they have when it comes to security. They don't take any liability. They take liability of their cloud environment, and then they ask their customer going to build a VPC that they have to, you know, choose their own security solution around it from the marketplace of the cloud.
I think we will see how, it will be interesting to see how successful the early edge applications are, and kind of how secure they are, and if anything nasty happens at the edge, what implications that will have.
I think so. And that brings to my next question, which is, you know, we all know, and Ian has explained very well, the importance of edge in order to enable this distributed network and the deployment of application and IoT services closer to the users to deliver the ultra low latency. But there are lots of open, question on security at the edge yet. There was the European agency saying, highlighting some security scenario like a rogue Mac node, or there are questions around, do we need some AI engine between the Mac platform and the IoT services that can do some device analytics and traffic analytics to be able to address the challenges, security challenges and security threat that comes from the application layer or from the device layer. Any view on that, Ian, please?
Yeah, I mean, as you know, Francesca, we've done some trials on using multi-access edge computing with a flexible SDN edge system. And what we found working with the operator, it was actually Vodafone with their 5G mobility lab in Germany. The RAN and that side of the core network out to the customer themselves is a lockdown environment. So, you can't get access to anything without raising about 20 trouble tickets just to get access to turn up the upgrades to the Linux operating system on the server you've put in that's out at the edge of the network within a couple of miles of the base station. Then you have to do the same thing to be able to open up the ports so that you can download all your SDN software, then so that you can download your applications, your MEC servers, and and provide all of the capabilities there. So you've got to pick your way through this environment, which is currently closed for very good reasons. And to be able to generate the new revenue has to be much more open. But in opening it will create security problems. And we have to put this as a kind of layered security situation. Those edge data centers, if you want to have 4G as part of your delivery process, which you'll have to for some time, particularly if you want a nationwide service, 4G has a one-way latency just on the radio of 10 milliseconds. So if you want to get to sub 25 milliseconds round trip services, which is generally what people say is a low latency service, and you're using 4G, you can't go much further into the network than your pre-aggregation, maybe your aggregation sites. So in the UK, each operator's maybe got 5 EPC sites. They've probably got about 200 aggregation sites, of which 25 or so used to be the NSC, RNC sites. And then pre-ag, you've probably got in the region of, actually it's around 1,500 because most of them are using the BT leased services at that point in the network. So if you're going to go to 1,500 sites, you're not going to have 1,500 manned micro data centers. So you have to have physical security. You then have to have security to protect the traffic in and out. You have to have firewalling to protect the parts of the network where you're breaking out of the operator's network and passing to, say you had an Amazon wavelength server that's stuck out at the edge. That is an interoperator interface where we would normally have a firewall. So that has to be taken into account. And then you have to take into account all of the possible interactions through the server infrastructure to be able to segment so that the apps only get access to what they're supposed to have access to, and you can't bleed across into the core network stuff and all that sort of thing.
And there's sorry.
Sorry,
and also No, I'm just thinking the more, if you're looking at utilities, you're looking at kind of industrial users that have traditionally had closed networks, and suddenly they're opening these up, and you're putting a lot of AI and automation in to actually defend these networks. You have this danger of entering an arms race where your defense has to be stronger than, I don't know, maybe BMW are trying to kind of find out what Mercedes are doing or the other way around. So you have to be very, very careful. And I think each organization is at this moment thinking through very, very carefully all of the scenarios and all of the implications of opening up their networks. And that will very much feed into a discussion as to whether they can trust mobile operators or systems integrators to come in. And I think what will happen is that there will have to be some kind of new form of service provider who understands the customer that they're talking to.
Yeah, I mean, and they're already emerging. We're seeing, for example, if I look at, say, Charles de Gaulle Airport, the IT service provider and network service provider is called Hub One, which has essentially become a mobile operator for Paris airports. It's got spectrum, it's got a relationship with a large vendor. Yeah, and obviously, they understand the dynamics of who does what in an airport. Now, whether they're using that network for everything, initially, I think what will probably happen is that in a lot of these verticals, the initial applications won't be the most sensitive. So I think in the airport, the number one application is when an aircraft comes onto a gate, you want to coordinate the catering truck and the fuel truck and the luggage loaders and all the rest of it. So it's an operational thing of how do you get turnaround from 23 minutes to 22 minutes. So I think you'll see that rather than running the air traffic control or something like that. Is obviously not a probable one.
Yeah. No. I know the people very well at Charles de Gaulle Airport. And of course, they will continue to run their Tetra network. They will continue to run kind of other networks that they've got. And actually, they're starting, the focus at the beginning is very much on 4G. So the 5G conversation is something that will come later on. And that's why I always try to differentiate between the 5G that was launched with lots of fireworks on the Thames last year, and what the full 5G solution that customers like the ones I represent kind of actually consider to be a replacement for the existing systems, the security systems that they have.
I mean, I think it's going to be one point that I'm taking from this discussion is that eventually relation with the customer and the vertical is very key. And it's important to engage in business and operational discussion rather than starting straight away from a technical and network requirement. So that is going to be key. And I think, service provider, they have to make their peak in addressing few verticals, because it's not possible really to scale and provide solution for all type of verticals. The advantage of service providers, and I'm now taking also the cold hat rather than the vice chairman of 5G security, is that as we go towards a telco cloud model where we can, work and build a partner ecosystem of VNF to offer network services as a service, then as part of that, we can also create a security partner ecosystem and offer security as a service, whether this could be, a virtual DPI, virtual filtering, virtual next generation firewall, or we could go even a step further and create template of network slice, each one with a certain security postures, which is defined from a chaining of specific security function. May I just ask your opinion on that?
It's interesting you said slicing now twice. And whenever, I don't know what Dean and Peter think, but whenever I've spoken to customers in the last 12 months about network slicing, they are getting round the current need of slicing by sticking the radio in a dedicated private network. Everything else they can handle. So they're not seeing a need to deploy any of the fancy network slicing capabilities in 3GPP, release 17, maybe release 18. So they're looking at sort of 2025 and beyond to be able to put this in their networks and monetize it. Today, it's about sticking dedicated radio into either 4G, as Peter says, or 5G, into the customer premises to give them that dedication, that isolation, and then either running the user plane part of the core to deal with the GTP, which is why I was also a bit confused about the European statement about rogue MEC devices, because you have to break into the GTP and you can't do that without the operator knowing. So I'm not sure how you get a rogue MEC device. So you either have the user plane on site or you have the whole core on site. And that's how you get a network slice. But I completely agree that security is a service. And one of the things you could, operators are saying, what am I going to use the edge for? Well, you've already got IoT devices in the current form attacking the networks because they've been compromised themselves. If you have an edge security, you can sell that as an additional revenue earner to the IoT customers.
I think for me, the first vertical, which is really going to indicate the levels of trust, is the telecoms industry itself. And so I think that unless, for example, operators provably trust each other for things like, say, wholesale neutral host models, and can I use another operator's network in building or in a rural area or along a railway, then why is an industrial company going to trust an operator if operator A doesn't trust operator B? You know, and you could argue that roaming ought to be a roaming slice. And you know, frankly, if it's not good enough for Vodafone roaming onto AT&T in the US to buy and feel they can get a secure and reliable slice on another telco, then why would Ford think that?
Mm.
Yeah, I think actually what could be interesting is actually slicing in the long term, when the factories of the future and maybe the ports and the airports, potentially together with a mobile operator or with a systems integrator, but I think they'll be looking to maybe slice their own networks rather than taking a slice from a mobile operator. So they will have their own network, and then they will be able to partition that. They will be able to have quality of service for particular kind of highly secure, kind of highly reliable services, and then they'll be able to switch over some of the less reliable services to the same network.
I'll say, Ian, you should probably have a view of sort of when the cellular industry sort of reinvents VLANs, basically.
Yeah, I mean, it's quite funny because, you know, 3GPP talks about slicing, and it's all kind of core network functionality and radio functionality. You know, that radio functionality now, as we go towards Open RAN, has to get replicated in this new thing called the RIC, the Radio Intelligent Controller, which is really a way of bringing in third-party radio application providers into your Open RAN to help control it and optimize it, or what we call SON in 4G. So, you know, we've got a few more security issues to deal with there. But you know, when you look at the wide area network, if it's just being used for EMBB, why do you need lots of slicing? You know, it starts to become something you need when you start running a network that's partly doing neutral host, partly doing smart city, partly doing the police, partly doing connected autonomous vehicles, all on the same transport edge telco cloud with the same radio. That's when it becomes a necessity. And
or someone else's towers and fiber.
Well, yeah, you know, that's the ultimate. You know, how do I virtually slice on somebody's physical tower? But yeah.
So it might end up being a little bit like the original SMS, where nobody really knew how they were going to monetize it. So this slicing, somebody may come up with an idea in 5 years' time that actually that we couldn't imagine at the moment.
I think I'd prefer to use the edge computing and probably network slicing as well. Could learn a lot from the errors of the telecoms industry with IMS. So if you think about IMS, and most people say it was an overblown standard that was too complicated and blah 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 blah, and was never successful. And actually, it found its niche as a voice over IP, and is now successful as VoLTE. So that's that. But it was designed as an open, secure applications environment for mobile applications. And operators and vendors focused on the network kit. They forgot the ecosystem, and they forgot that there isn't one application that's going to pay for all of the investment. You have to put the environment in place, enable the application developers, and then they'll start bringing things forward. And it's that, you know, and if you look at what proved at that point was about 2 years after IMS was declared a flop, some West Coast fruit company launched that little thing called the iPhone, which is effectively an IMS. And Google came along with Droid about, a year later or something like that. And the rest is history, including all of the value-added services that the operators used to make all their profit on. That is history as well. They're now all on the OTT providers. So if you look at slicing, you look at edge computing. If you don't build the environment, the ideas for the applications that are going to use it are never going to come, because you don't have application developers developing for environments that don't exist.
Yeah, apologies, Ian. Yeah, of course, that's the public safety. What we used to do is we used to press a red button, or kind of just press a button to talk. And then suddenly 3GPP came along and said we need to build a complete IMS to replicate emergency calls. So that was interesting.
Yeah, I used to work for Motorola, and our IMS was actually our push-to-talk system. So yeah, one became the other, you know.
I spent many years writing about that. Actually, in public safety is interesting because I think that what we might see is a distinction between, let's use a restaurant analogy, a hand-carved slice, where it's sort of beautifully done by an artisanal chef that is suitable for public safety or one or two other critically important, expensive use cases. But the industrial sort of slicing machine, that's a long way out. But it's the handcrafted, guy at the table side.
Yeah, I think it's still far away. Nice concept, I love it, but I think we're still a bit far from it. Especially the dynamic network slicing, where you can really programmatically and deliver a context where network slice. Anyway, we will have to stop here because we have few questions in the Q&A box. I'll ask Mark to forward the question to the panelists, please.
Yeah, sure. So yeah, thanks very much, panelists. A very interesting discussion. So we've got a few questions in from the attendees. So one was asking, do you feel the NESAS, which I'm assuming is the Network Equipment Security Assurance Scheme, has missed aspects from their security baseline and associated audits? That was from Ros Tomlinson. I don't know who wants to take that one.
That could take quite a long time to answer. I think I've got one. I've got one. I reduced my presentation to one bullet about that, but it's interesting. It's very much, I think, it's still a work in progress between 3GPP and GSMA, and the idea eventually is to replace the existing common criteria solution, and there are separate documents per network function within 3GPP that are now being kind of encoded by GSMA into security assurance documents. I imagine, like everything within this industry and within 3GPP, it's a work in progress, and we will see over the next year or two kind of how successful. We need to get certification bodies in, accreditation bodies in to kind of work on this. I don't know if Ian knows anything about this. I'm not.
No, I'll put my hand up. I'm not going to talk about NES. It's not my area of expertise, I'm afraid. So.
Yeah.
Okay, well, thanks very much for doing your best to answer that. We had another one in. I know Ian's answered this in the Q&A box, but I think so for everyone else on the meeting. So we've got a question about app and IoT developers and what the steps are they can take to make their offerings safe when connecting to OEMs, MNOs, and infrastructure, and whether there's a toolkit for best practice, particularly around SMEs.
Not something that I'm aware of, and I suspect it's going to be very dependent on the specific use case, and what connectivity it needs for what purposes.
Yeah, I think, for example, in the US, we have the large nationwide public safety program, FirstNet, and they have schemed to the public safety needs to verify kind of app by app. So there are a number of SMEs that put up their applications for the FirstNet team to have a look at. So I think here it's a very the vertical and the critical communications environment is a very, very different environment to the consumer environment. So.
I think also, there are bodies like National Cybersecurity Centre in the UK, and I think also that it's probably worth pointing out that initially, at least, very few apps or IoT devices will be 5G only. A lot of IoT devices have modular connectivity interfaces. So depending on your particular use case, you can connect it with fiber or with 5G or 4G or Wi-Fi or whatever. So the actual device may well be, an application may well be independent of the 5G security regime.
But thanks very much for those answers. I think the other interesting point around IoT and security is obviously kind of on the consumer side. DCMS have recently been consulting about kind of rules and there's obviously kind of testing regimes coming out from the likes of ETSI and GSMA. So I think there are things going on there. We've got a question in from Vanita. I hope I've probably pronounced that hopefully correctly, which says, in this current telco data center, security has been delivered by point solutions. Will it be the same in LTE private networks where IT admin has to learn about various things like FW and deep packet inspection, etc.? I don't know who wants to take that, or whether you've got a view on that from the panel.
I can normally talk about just about anything, but that's starting to stretch me. So.
Yeah, one of the things I'd say is it probably depends on what sort of private network you've got, and what sort of traffic's coming over it, and what the devices are, what's able to get access to that network as to how much DPI you need, and whether it's a case of firewalling and more the traditional types of security on the system, or whether you need to do anything extra as well.
I suspect it'll be also dependent on the industry sector, their scale, and what they already do on security. And so, if it's a property company building a private network for a shopping mall, they'll probably have a very different security skill set to a military base or a oil rig.
Yeah. Or if it's the City of London building a connected autonomous vehicle network using 5G, when most of these vehicles are out in the wild and someone can sort of won't really have a dashboard anymore, but you crawl under the dashboard and get access and start hacking things. That's going to have a much different security paradigm to something that's just that's being used to control industrial machines in a purely private network.
Okay, I think that's most of the questions from the Q&A. I had a couple of my own. I guess if you go back to your kind of security 101, you've got your confidentiality, integrity, and authentication. And traditionally, people tend to worry about the confidentiality. So, kind of, are you encrypting everything? As we move towards more verticals, particularly in 5G, and kind of people who are interested in the end-to-end risk and applications, do you see us moving towards more a different focus on that security model, or do you see that security model kind of holding up through 5G and private networks?
Yeah, I have a slide, I think slide 6 or 7, where I show the key management with it, PP. And I think when we get to it, you will see just how complex kind of encrypting networks to end really is. So it's getting very complicated.
I think that one of the things to consider here is the diverse network ownership landscape. So the term end-to-end is going to be less meaningful because there's going to be lots of boundaries in the middle. I did an estimate this week which suggests that maybe GSMA is no longer representing the majority of 3GPP network owners and operators, because there's now so many private cellular network, public safety utilities, fixed wireless access service providers. And that's only going to continue. The first industry that 5G transforms is the telecoms industry, and that's happening already. And so you're going to have separate networks for in-building, maybe along road and rail lines, rural areas. You might find communities building their own networks. And so there's going to be lots more network-to-network boundaries. And I think that is part of the problem, as well as the devices, and sort of almost like going down, not just the devices, but you may well find that individual silicon components within a device are almost separate endpoints in their own right. You already see this with, say, cars. Cars might have 1,000 sensors and a huge amount of silicon content, or a phone or a PC. Some of those will have their own independent connections as well. So a jet engine on a plane doesn't necessarily use the plane's network. It's probably got its own radio in it. and communicates independently, because the engine is owned by Rolls-Royce rather than by Boeing or the airline. So it's going to be a sort of a lot more complicated and heterogeneous atmosphere environment. Now, for certain applications, you'll be able to define end to end, but on the others, the ends themselves will look increasingly arbitrary.
That's really interesting, and I'm sorry, I think we'll cut it short there to keep to time. But thanks very much. Really good discussion going on, I think. So if there are any other questions, then we'll pass those on to the panelists and speakers later on.
Thank you.
Thank you, Mark, and thank you, Francesca, and all panelists. If I could just ask Peter to...
Yeah, that's fine. It just said that my connection was becoming unstable 10 seconds before I speak, so let's see what happens. I'm probably down to about 8 now. Let's have a look. We're there.
Thank you.
I share my screen. Let's see what happens. Let's go back. Okay, can everybody see that?
And
can you see that? No, yeah, I had to press share. Now there we go.
that's perfect.
Okay, I don't know if I put.
Thank you.
Then I do the slideshow. Okay, yeah. So the challenge is on then. Let's see how this goes. So luckily, we've unfortunately kind of introduced some about. Okay, so new security architecture and function within 3GPP. You can read that for yourselves later. I've already explained quick staticity. Okay, so let's move now to 3GPP. So basically, 3GPP was set up for the 3G environment back in 1998. 6 original organizational partners, with India joining for 5G around 5 years ago. The groups, we have 3. So I think what's interesting about 3GPP actually is the fact that there are 20 market representation partners, including a lot of the verticals that are actually feeding into the 5G work. And 3GPP actually has over 60 liaison committees as well. There are 3 main groups within 3GPP. We have the RAN, the radio access network, we have the service and system aspects, and we have the core networks. There is, as I already mentioned, there's a specific group, SA3, that is dedicated to security, and a group, SA6, that is focused on mission critical applications. There's very much a waterfall model of moving through requirements for SA1 at stage 1 into a stage 2, and then the CT group, the core network and terminals group, cleaning up on protocols. And release 16 is now complete, and 17. So the first 2 phases, as it were, of 5G have now been. What needs to be secured? I think fortunately Ian already mentioned the ITU triangle. So the first phase of 5G was very much focused on enhanced mobile broadband, but the more interesting part, particularly from the critical verticals, are the massive machine type communications and the ultra reliable low latency communications. We are now moving in a full 5G environment. We're now moving towards a service-based architecture. So the user plane will continue with reference points, but now we're moving towards a producer and consumer, very much virtualized network function type of, and ORAN was already mentioned as well by Ian, which is now kind of building on top of 3GPP, disaggregating and making the RAN even more intelligent, which has its pluses and its minuses. And the final picture here is of the domains. So there are 5 or 6 network domains that are relevant for security aspects, network access domain. So yeah, network access, the network domain, the user domain, application domain, and a new domain regarding the service-based architecture. Oh, I went straight to the end. I knew it might happen. So securing 5G, particularly on the side of critical verticals. So the diagram at the bottom, I thank Anand Prasad and a few of his colleagues. This was produced following the end of phase 1. We have very much a layered approach to security, and we were also discussing where the boundaries may lie. We have a security anchor function that is currently within the AMF, so the mobility function, but that could at a later stage be separated out. And we now have security, the SEP function, which is the security proxy function at the edge between two networks. So previously, this was not available. So we're moving within 5G. We are continuously clearing up a number of the threats that we see from 4G, and perhaps introducing some new ones as well. This was the key hierarchy, derivation, and dependencies slide that I mentioned earlier. So there is now a very, very complex key hierarchy, a key management structure within 5G, where an initial key is generated, and then that moves through from one end to the end to end, as it were, across borders, protecting and providing authentic and mutual authentication. 3GPP SA3's work is never done, never finished. There's always a need to secure kind of ever-evolving solutions. Some of the more interesting topics that were touched upon in release 16 and that we're now looking at within release 17 are authentication and key management for applications. So we're now looking at securing all the way from the physical layer up to the application layer, together with a number of industry partners. Integrated access and backhaul is an interesting topic, together also with the advanced V2X PC5 interface. So these are ways of increasing coverage and resilience within future 5G networks. We mentioned the 5G LAN, and also SA3 continues to work together with the rest of the 3GPP community to enhance ultra-reliable communications and massive machine type communications. As we move towards virtual machines, containers, cloud environments, we have a number of challenges, including lawful interception. I very briefly mentioned the new security assurance initiatives being worked on between 3GPP and GSMA. And here I've just listed a number of topics that are dealt with within the core document that is produced by SA3 regarding 5G, which is the TS 33501 document. And this document is several hundred pages long and has a series of annexes that go into quite some detail regarding these. So probably I'm very close to the end of my time. So the key takeaways here are that full 5G is on its way. Critical verticals will not touch 5G unless it's secure, so this is non-negotiable. The 3GPP community continues to grow and diversify. The SA3, SA6 group working very hard to continue the work. 5G incorporates incredibly diverse and complex scenarios. If implemented correctly, 5G will be a very secure system. Most importantly, I think security must be by design, end-to-end, through across all borders, and continuous and never end. And I believe we are living in interesting times. And there are some of my details and a picture. Now that we're not traveling as much as we used to, so we're not spending 30 weeks or more on an aeroplane or somewhere in the world. So I just put a picture of me in Sydney, Australia, just to end my presentation. So I will stop sharing now, and
thank you so much.
Thank you very much for that.
Thank you so much, and I'm sure we all wish we were in Sydney now. I'm now going to hand over to David Cook, who's going to talk about the evolution of standards, compliance, and certification. Over to you, David.
David, you are on mute.
Hi guys, sorry, I'm just trying to find how to share my screen. I had it up a minute ago.
It should be at the bottom of your Zoom screen. There's a button in the middle.
Yeah, it says share screen, but doesn't show the presentation. Let's try that one.
If you have two screens, you might have to choose the right one where your presentation is.
Let's share the screen, see what that does.
That's perfect, thank you.
Does that work?
Yes, if you could just put in full. Yeah, that's great, thank you.
Fantastic. Well, hello everybody. Thank you very much indeed for giving me the time to talk, I guess, very briefly over the next sort of 8 minutes or so. Just a quick introduction to myself. So I'm David Cook. I'm head of digital sector within BSI. So BSI, for those who don't know, we're the British Standards Institution. We are the national standards body for the UK. We have several functions, but principally we have a memorandum of understanding with the UK government, and we have a public function to support the UK economy in developing standards both nationally and internationally. My role within BSI is really to look at what's currently going on both nationally and internationally within our committees. We have something like 15,000 subject matter experts or committee members working across all sorts of different areas, from standards on bouncy castles all the way up to quite complex medical devices. My focus really is on digital, and we have some specific committees within our committee groups that are looking at specific standards, technology standards, and security being one of those. I'm not going to talk about technology in the next 8 minutes or so. I'm really going to talk about, what's BSI's sort of view on supporting industry, on developing standards for security across digital infrastructure, and more particularly 5G. So we work across all sectors. We have something like 90,000 clients globally sitting within all sorts of different areas, and the complexity that they're grappling really with is not just the application of the technology, but the application of the technology as it is applied to people, process, technology, that kind of digital transformation sphere where they're looking at all of these different types of solutions and themes, and then looking at how those then would be applied into their different particular area. We've mentioned things like airports and roads and utilities and different areas who are considering all these different thematic areas of technology, but then also looking at specifically the connectivity of those different technologies and how they will apply 5G. So if we look at putting 5G into the core of that transformation, we started to see whole series of gaps, I guess, risks and issues related to the application of 5G across all these different particular areas. Some of them have been mentioned today, but things like, you know, how are we going to interoperate against, you know, 5G and non-5G systems, all the way from the network, a physical thing, all the way through to an application, and 4G and 3G and ultra narrowband networks will all need to be considered on how they would be integrated and interoperate securely. Looking at things like physical security and how do we protect street furniture, for example, that might have 5G aerials and other technology connected to them. And then things like synchronization, timing is quite critical within 5G. So how do we make sure we're securing that, and what is the risks and issues associated to those particular areas, and maintenance and others. The point of this slide really is to say that, you know, it is complicated, and what we're trying to do is work with the UK government and our clients beyond just the technology areas, but looking at the transformed services, you know, whether it be an ambulance connected by 5G or a rail system or some form of critical national infrastructure, which then affects people, process, as that technology is applied to deliver an outcome. So we started to do a lot of work thinking about this complexity of this space. All of our committees are working on thinking around these particular areas, and we've started to try and kind of map out, I guess, the gaps in the landscape. BSI has been in the security standard space for a very, very long time. The ISO 27000 series was born here in the UK. There's now 150 plus different derivatives of it. But what tends to happen is security is really seen as something that you do from a compliance perspective. You know, it's a regulatory requirement. I need to apply it, so therefore I'll get certified or assured that I'm complying with 27001 or 27701 or whatever that is. What we're trying to do is make a cultural change, and this is not just around security, it's around all standards, that actually we should be looking around enablement, moving away from just risk management to considering security as a value creation. Using security as a way of driving operational efficiencies in a trusted way, but also then using that to drive innovation and growth. So how can we use security as a catalyst to enable us to innovate, develop new products and services safely that are trusted, and then obviously allow us to grow more effectively? And what we've been doing is trying to work with our clients and our customers in embedding security practice within the lifecycle development of a product or innovation. So how do we look at things like going from left to right to look at common approaches? So how do we build robust security approaches into the development of our systems, our products, our technology? And how do we manage and embed that best practice at the point of design and implementation? And how do we manage the portfolio more effectively? I was going to put a slide up here which had all of the 27000 series standards, and then all of the other standards that relate to security in different areas, whether they be telecommunications or others. And it's immense. And really, and BSI is only just one organization, you know, internationally working on standards. And I think part of our role is to try and help organizations manage their security portfolios much more consistently, and try and help the industry to remove the complexity. You know, where do I need to apply what at what time point within the development cycle or delivery of my product? And making sure that products are secure by design. It's often used as a term, but actually if we can try and help organizations really start to kind of build this into the DNA of their design and their products, then we will see the accelerated adoption of new technology, trusting new technology. But key to all of this really is around how do we share knowledge more effectively. We're doing lots of work in terms of bringing together practitioners, those who are working in industry who are out there trying to implement new solutions and new technology, trying to transform their businesses, their organizations using technology embedded like 5G. And how do we help industry really share that knowledge and share that best practice, which allows organizations then to accelerate the adoption of this new technology. And obviously, there are frameworks and existing standards that exist. What we're trying to do is develop a programmatic way of capturing best practice and good practice and helping then industry disseminate that out to their organizations. We've also just launched a new product. One thing that we recognize and many of the standards organizations globally do is in this very fast-paced world of change and transformation, we need to develop standards much faster. You know, we can't be in the situation where we're spending 3 years from start to finish to develop an international ISO IEC standard. We need to do this in a much more flexible, dynamic way. And we've launched a new product where we're now going through much faster iterations, much shorter cycles, going at the speed of industry. So they are formal standards, but they'll be released within weeks rather than months and years. And that's something we're going to be doing more of over the next coming months and years to try and really accelerate the development cycles of delivering standards and best practice. And just finally, because I'm out of time, I've got a very short window here, is really for us, it's about keeping up with the pace of change in technology and business disruption, looking across technology, people, process, and those different intersections. How can we help stakeholders be more efficient in developing and disseminating and sharing best practice, achieving those kind of very aggressive, rapid growth and adoption of new technology? And for us, really, it's about how do we help organizations really culturally embed security standardization within the DNA of their design and delivery of products, which currently right now perhaps isn't the case. And that's me. Thank you very much.
Thank you so much, David. Our next speaker is Russell Gundry, who's going to talk about industry-led innovation to accelerate and incubate security solutions. Russell, over to you.
Thank you very much. So, can everybody see my screen?
Yep.
I'll take silence as yes. So I'm Russell Gundry. I'm head of innovation strategy at Plexel and Lorca, and I'll explain more about what that means. The purpose of this presentation is to provide an ecosystem view of innovation, and specifically 5G innovation. Lorca is a cybersecurity innovation platform, brings together multiple parties to that end. This is broadly what we do. So we take a view of what the future of being an integrator might look like, and we bring together investors, industry, startups, academia, government, and scale-ups in order to tackle challenges that matter. We do that across a number of themes, incorporating cybersecurity, mobility, and inclusion. And I think it's helpful to explain the context of where we are. So we're located within what was previously the home of the Olympics, and that's interesting for a number of reasons. So within this 560-acre campus, there are 5 autonomous vehicle test routes. So it's an autonomous vehicle test bed, and multiple trials happen here. The Bird scooter mobility trial worked between Here East, which is the campus that we're based at, and the Westfield Shopping Centre, which you can see over there in the distance. From a consumer perspective, it's a very interesting environment in the sense of being land which is a public-private collaboration. So in terms of user base, there's one of the busiest shopping centres in Europe, a very large residential population, UCL are basing up to 40% of their activity here, and they're testing Airbus wings in the campus as we speak, so being able to provide real-time information back to the manufacturing process. So there are multiple use cases that exist within the campus that are enacted. In terms of scale, it's a reasonable scale for 5G implementations, in the sense that you've got a bounded area over which there's a requirement for a significant amount of data transfer. And in addition to the use cases that I've mentioned, there are consumer-facing facilities like the West Ham Stadium, which, as I think you'll know, is a central place for 5G trials. BT Sport is also based in the campus as well. So from a sort of 5G consumer perspective, it's quite interesting. In terms of how we lean into that challenge as an accelerator, so we bring together a platform that's essentially convened by ourselves, Plexel, DCMS, Deloitte, CSIT, which are a leading institution for secure technologies based in Belfast, SOSA, who operate out of Tel Aviv and New York, and Crest in Lancaster. In terms of corporate members, we bring large organizations on board in order to fulfill the platform aspect of what integration might look like. They include LBG, Dell, KX Kadelsky, and Global Cyber Alliance. And we've so far taken 72 companies through our accelerator program, and they range from penetration testing to skills development to working with the European Space Agency on satellite or secure satellite communications, through to NHS applications. So there's a broad range of capabilities represented within that group. In terms of how we do that, so we bring investors together through a finance forum to understand what the investment landscape looks like, to tackle some of the barriers. Typically, we see that there are some gaps in that process, and recently we've seen a lower deal flow, but a focus towards higher value deals, and some notable deals going through, like Privitar, which is one of our cohort members. We host an innovation forum to essentially set some of the challenges for what our startups will respond to in order to focus their interests. The theme currently is the connected economy, so looking at the proliferation of connected devices and how they can be secured. We run a series of needs accelerators, so they are really an attempt to go beyond the theatre of sales, where large organisations are relentlessly pitched at by startups, and really what that attempts to drive is a much more intimate strategic conversation where large organisations could be much more open about their roadmaps and bring that together with flexibility in what startups can provide. And essentially we act as a facilitator in that process. And also the industry advisory board. I mentioned I mentioned the organisations who are involved from an industry-led perspective, but also people like Robert Hannigan, who chairs that board. So that's really a sort of high-level governance structure to ensure that the programme responds to what are current and needed challenges. In terms of the offer to accelerator members, I won't read all of this slide, but the intention of the programme is not to take equity or IP. What we provide is expertise in scaling startups, and also being able to link that scale together with what is useful to UK PLC. Deloitte are at the sort of leading end of cyber capability in terms of large advisory company. They provide technical expertise. I mentioned already the engagement with industry and the BD together with large organizations. We work with companies to create proofs of concepts and help them to develop their products. A lot of the focus is on expanding internationally. So I mentioned SOSA as an example of that previously in terms of building connections with New York and Israel, amongst others. And a lot of the input from investors is around the sort of the challenges of how to get ready for investor pitches. We also run an innovation center, which is at the heart of the campus that I showed you a picture of just a minute ago. We're quite proud of how successful that's been. So to date, our companies have raised £153 million of revenue since joining the programme, 3 successful exits. Apologies. I think I said revenue. I meant to say investment raised. 153 investments, £26.5 million worth of revenue, 800 contracts, 500 POCs, and 850 direct jobs. So in terms of economic impact, the programme has been substantial. In terms of how to get involved from a partnership perspective, we welcome partnership in the programme. If you'd like to get in touch, please do. There's an email address at the top, or my email is russell@plexel.com. I showed that at the start. So we are actively seeking new partners to join the programme. We will be recruiting for the 6th cohort. So if you're a startup and interested to apply, then please do. And of course, we build a thriving investor community, including office hours and building relationships between investors and the cybersecurity landscape. Finally, I just want to mention that it's an opportune time. So we host an annual cybersecurity conference, and of course we try to broaden the theme of that conference to not just kind of cover technical capability alone, but we're looking this year, as I mentioned, at the connected economy. There's a series of high-profile speakers that will be participating. There'll be workshops and a daily broadcast taking place from 4:30 to 5:30. So I would encourage you to register for that. It is free to participate. It's on the website, is lawcalive.co.uk, and it's a good way of meeting and interacting with our community. I think that's me covered. So I'll be delighted to answer questions, but I believe we're also slightly over the session time. I think I was less than 10 minutes, but I'm sure you'll tell me if you think different. Thanks very much.
Thank you, Russell. There's a question for you in the Q&A box, so please feel free to answer in writing. And in the meantime, we're going to move on to Woonhao Chin, Research Manager at Toshiba Research Europe, who's going to present his presentation now.
Thank you, Ivana. Let me try and share my screen. That's it. Right. I hope everyone can see my screen now. Very happy to have all of you here. My name is Woonhao, and I'm the research manager of Toshiba Europe's Bristol Research and Innovation Laboratory, obviously based in Bristol. It's a pleasure to be giving this talk. As we only have 10 minutes, I'll be very brief and try to finish off on time. First, I'd like to introduce Toshiba's Bristol Research and Innovation Laboratory, and I'll spend the rest of the time talking about 2 cybersecurity projects that we are working on, keeping in mind that some of the things that we are doing are not specifically 5G related, but most are generic enough to be applied to 5G as well. Now, just let me briefly delve on, introduce the Bristol Research and Innovation Laboratory. We are part of Toshiba Europe, and part of Toshiba's corporate R&D arm, which have units all over the world. We are one of the only two units within Europe. The other is in Cambridge. We are formed in 1998, and we were first known as Telecommunications Research Laboratory, which some of you may have heard of. The name Bristol Research and Innovation Lab is still fairly new, only been used since last year. Our activities range from wireless communications to cyber security, and we have been involved in a number of standardization bodies over the years, from IEEE 802 to ETSI to 3GPP. I myself have been involved in 3PP ran one on and off for the past 15 years. We are also working with a number of top universities on the longer term research, such as Imperial University of Bristol, Oxford, and so on. Now, as a company, we are very interested in security in cyber physical systems. A lot of you may have known Toshiba for its laptops and televisions. Unfortunately, in recent years, this business has been very difficult. So we are no longer making any of those. So the Toshiba laptops you see are actually made by Sharp, and it's the same with the TVs. They exist only in brand, but not in spirit. But we are still involved in many businesses, just not many of these are consumer facing. For example, energy systems, infrastructure systems, semiconductors, and so on. And seeing how software and data is getting more important, we are transforming ourselves into a cyber physical systems company, which we believe it's the way to go. And one of the cornerstones of all cyber physical systems is security, without which we'll make it a very poor system indeed. So hence our interest in all this. And one of the things that we are particularly interested in, as you can see from the slide, is actually edge devices, which brings us to the first project that I'm going to talk about. The first project is called Synergia. It's short for Secure by Design End-to-End Platform for Large-Scale Resource-Constrained IoT Applications, which is quite a mouthful. Hence, we have the short form. So this is a 2.2 million project co-funded by Innovate UK, comprising of 6 partners, including 4 SMEs. I think some of the SMEs is also involved in the local accelerator as well. The vision of the project is to make IoT secure, and one of the trends of IoT networks when we were writing this proposal was that we realized that a lot of the computation in network is now being pushed to the edge to improve scalability and to decrease latency. But this also results in new challenges in terms of security. Hence, this project would want to address some of these challenges. And some of the things that we are looking at here would be secure systems for end devices, and also AI-based intrusion detection. Now, I'm not going to spend too much time here, as this project is just going to start in October. But do stay tuned, because we will be pushing out updates as we get results from this. So the next project is one that's really been started. It's called SWAN, for Secure Wireless Agile Networks. It's a joint industrial and academic program to address security systems in security issues in wireless networks. And this is funded through EPSRC's Prosperity Partnership Call, which is a government initiative to actually transform society to make it prosperous. The SWAN project itself is a 6 million 5-year research program, which is co-funded by EPSRC, along with Toshiba Europe, Rook Manor, GCHQ, and the University of Bristol. So the main motivation of the project is due to the fact that wireless is becoming more and more important to everyday life, especially in times like this where you can't go anywhere. If you can even imagine your Wi-Fi being down for a day, that would be extremely disastrous. So the truth is, we can't live without wireless anymore, and it has become part of our lives. And like all things digital, they are very susceptible to cyber attacks and other induced failures. Hence, the aim of this project is to develop secure wireless networks that are resilient to these threats as much as possible. And the main focus of the project is actually to look at the RF design. So first and foremost, the program will identify various vulnerabilities in the RF interfaces. And this is the stage that we are at now, keeping in mind that this is a 5-year research project, and we are right at the initial stage of it. Then it will try to develop techniques to detect and mitigate against attacks. And last but not least, try to create technology for software-defined radios so as to create more resilient and secure systems. So some of the ongoing work in SWAN are the use cases which would be relevant to us. So for example, in GNSS, we are looking at jamming and spoofing of such systems where you can mislead a device as to where it is, and sometimes with very drastic consequences. And for Wi-Fi system, we are looking at tampering and spoofing of such systems, where you can have a man-in-the-middle attack, and very frequently using very low-cost devices, which you can sometimes really buy on Amazon for less than 100 quid. So, well, yes. And also, in terms of keyless car theft, with spoofing and denial of services, and this has made the news quite a few times over the past few years because of some of the very expensive cars that has been stolen using this way. Last but not least, we are also looking at IoT systems such as LoRa, where you can have spoofing and tampering and denial of services. We are at the same time, we are also looking at some of the countermeasures that to be taken, including detect and defense mechanisms, and also work on some of the RF interfaces to make them more robust and resilient. So that in a nutshell is basically what we are doing. But stay tuned because we will be publishing some of our findings on our web. You can also follow our Twitter account, and we do have a LinkedIn page as well. So that is what I'm going to talk about today. Thank you very much for your time.
And thank you all our presenters today. Just as a reminder, these are our presenters today, and I'm just going to hand over back to Mark and Francesca to close the event for us. Thank you.
Yeah, so thank you everyone. That was for joining this session, also for your interactive question, and for all the insights that you brought in into this session. So thank you everyone. I think we're recording this session, right? It will be available as a webinar.
Yes, we are, yeah.
Share it, with your colleagues. And thanks again. Bye everyone.
Thank you. Thank you, everyone.
Thank you very much, Francesca, for organising such a great programme over the past couple of days, and for the variety of interesting topics which have been covered. So yes, thank you very much for attending, everyone else as well.
Thanks. Thank you. Bye-bye.
Thank you, everyone. Bye.